What if I told you that you might be unkillable? That you're impossible to actually delete from existence? It sounds like something straight out of a comic book, but this idea actually comes from one of the most successful and, let's be honest, weirdest theories in all of physics. And to get our heads around it, we have to start with one single, pretty mind-bending question.
So let's just ask it right up front. From your own personal perspective, are you immortal? To even try to answer that, we've got to take a trip into the completely bizarre world of quantum mechanics.
Okay, so the first hurdle we all have to get over is just how strange reality is at its most fundamental level. Seriously, the rules that we think govern our everyday lives, they totally break down when you look at the tiniest parts of the universe. Look, in our world, things are predictable, right? If you kick a marble the exact same way 10 times, it's going to land in the same place. But down at the quantum level, oh boy, if you could kick an electron 10 times in exactly the same way, it would just show up in different spots. It's like the universe is rolling dice. At the smallest scales, randomness is the name of the game. So how do scientists even deal with all this randomness? Well, they came up with this brilliant idea called the probability wave. Now, this is a really crucial point. An electron isn't some tiny little ball. It's more like this vague, shape-shifting cloud. And this wave, it's not made of matter or energy. It's a wave of probability. It just tells us the chances of finding the electron in all these different places. Let's make that a little more real. Imagine you have an electron gun in your apartment, okay? You fire it 100 times. 80 of those times, the electron pops up in your living room. The other 20 times, it's in the kitchen. What that means is the probability wave for that electron is like 80% smeared out in the living room and 20% in the kitchen. The math works perfectly, every single time. But it leaves physicists with this huge, nagging philosophical problem. And that problem has kicked off a debate that's been raging for a century. If this whole probability wave thing works so well, what is it actually telling us about the nature of reality? This is where our story really splits into two totally opposing camps. So, yeah, the big question is, what is this whole quantum story really about? To simplify this massive debate, we can kind of think of the two main schools of thought as the linguists and the literary critics. And believe me, they are screaming at each other over the true meaning of all this. Here's the core of the fight. The linguists, they say quantum mechanics is just a language. It's a set of rules, a grammar for predicting what happens in experiments. That's it. Follow the grammar, who cares about the plot? But the literary critics, they insist it's a story about reality itself, and that our job is to read between the lines and find that hidden meaning. Now, this isn't just some academic squabble, because the answer has massive consequences. I mean, depending on who's right, you are living in a radically different kind of universe. Either there's just one reality, or there are countless versions of you, right now, and each one is just as real as you are. This is the famous battle cry of the linguists' camp. It's super pragmatic, totally no nonsense. They argue that physics isn't about giving us a warm, fuzzy picture of the universe. It's about making predictions that we can go out and test, period. So the bottom line for the linguists is this. The theory is just a tool. It doesn't tell you what an electron is. It could be a tiny marble. It could be Detective Pikachu. It doesn't matter. It only tells you where you're likely to find it when you look. So stop making up fairy tales and just use the math. But the literary critics are like, no way. They are the many worldians, and they are totally convinced that the math is telling a story about reality. And that story is that all the possible outcomes of a quantum event actually happen all at the same time. Here's how they think it works. Remember that electron? 80% chance it's in the living room, 20% in the kitchen? Well, the moment you go to look for it, the entire universe splits. In one branch of reality, the electron is in the living room. In another, separate branch, it's in the kitchen. And both are equally real. And here's the part that'll mess with your head. You split too. One version of you sees the electron in the living room, while another version sees it in the kitchen. The linguists are shouting, stop it. If we can't see or test these other worlds, it's not science. But wait a minute. There might just be a way to find out who's right. A thought experiment so extreme, it could prove you're immortal. Or, vaporize you trying. Welcome to the ultimate test, quantum suicide. The setup is, well, it's simple but terrifying. We take our electron detectors and we hook them up to a nuclear bomb. If the electron lands in the living room, boom. If it lands in the kitchen, you're safe. Now all we have to do is shoot the electron. With every single shot, these are the odds you're facing. An 80% chance of being instantly erased and a 20% chance of survival. Would you push that button even once? Okay, this is where it gets really profound. If the linguists are right, and there's only one universe, it's just a matter of time. The odds are going to catch up with you. That 80% will hit, and you'll be vaporized. Simple as that. But if the literary critics are right, something impossible happens. With every shot, the universe splits. Yeah, countless versions of you are annihilated. But from your conscious perspective, you can only experience the timeline where you survive. One you is absolutely guaranteed to be in the branch where the electron landed in the kitchen. And that's the only reality you will ever be aware of. From your point of view, you just keep surviving. At first you think, wow, I'm really lucky. But after, say, 100 successful tries, the odds of that happening in just one universe are, well, they're shown on this slide. It's a 1 followed by 70 zeros. At that point, your continued existence would be practically impossible, unless many worlds were real. You would have just learned the universe's deepest, darkest secret. So, what does this mean for you sitting here right now? Well, if the many worlds interpretation is correct, the implications for your own life are just staggering. This is the core idea of quantum immortality. If every possible quantum outcome actually happens in some branch of reality, then no matter how bad the odds are, there's always a branch where you survive. A tumor starts growing, but some stray cosmic ray just happens to kill it. A washing machine falls off a roof, but by some 1 in a trillion quantum fluke, its atoms phase right through you. From your point of view, you just keep on surviving against absolutely impossible odds. But, and this is a huge, huge but, don't go testing this. For every one version of you that gets insanely lucky, bazillions of other versions of you don't. They suffer the terrible consequences, and they are just as real as you are. So, for real, if you see that falling washing machine, move away. Please, save as many versions of yourself as you can. So in the end, we're left with this choice. If the shut up and calculate crowd is right, there's just one you in one world. When your story's over, it's over. But if the many worlds idea is true, then no matter what happens to you, you can know that some version of you somewhere is living through the best possible timeline. And that leaves us with one final kind of haunting question. If you were sitting on that bomb and you were absolutely certain that the universe would branch, guaranteeing your conscious survival, would you push the button? And what does that say about who we really are?